I guess we're live. Something like this. Have you ever heard this song? It's amazing. It's just amazing stuff. So this song was popular a long time ago. I don't even know if this is like the original version. But let's see. I think it came out somewhere around like the second year I was teaching or first year I was teaching. Here it comes. Okay. It's a fun one. It's a fun one. All right, we'll pause this. Hey, kiddos. Welcome back. So this is Monday's lesson. Lesson 9. I got stuff set up here. I got my little whiteboard. The way this week is gonna work is that yes, we've got our 4 lessons. Lesson 9, lesson 10, Monday and Tuesday. They're going to be using like the same materials, the same stuff that we normally be using. Ooh, look, I got a haircut. So my wife, she gave me a haircut, and she said to me, so we're on the back deck, and she's like, near, and she's like, this is really easy. This is a lot easier than when you were younger and you had more hair. And I was like, thanks, honey, thanks. Okay. So anyway, so I got a haircut. I can trim the beard myself, but getting this, I mean, there's no getting this right, but like at least it makes me happy. All right, so we're gonna have 2 days of normal lessons, and then we've got and then Wednesday and Thursday. What I've got for you is 2 videos, because as I looked at the lessons, I was like, there's no way I can teach this from home. You are welcome to go ahead and try and like explore those lessons on your own. You just email me and be like, Mr. G, send me the lesson from Wednesday that you skipped, or send me the lesson from Thursday that you skipped. I will gladly send you the links. They confuzzled me, and if you can understand them, whoa, like props to you. All right, so let's do a little check of things. Let's see, we got split screen. We got what else we got? We got just me, the split screen. We got, what's that? Just a screen, and then we got this thing. All right, hey dude, focus. Why is it out of focus? Oh man, can we not use this? What's up? Okay. Jeez, this is horrible. All right, do, yeah, auto, there we go. Okay. So I was hoping to maybe like show a little bit of some work in some of these videos. So we'll see. As evidenced by that, maybe this is not the way to go. But all right. So let's go to some of the lesson stuff. Let's see here. We still streaming? Oh yeah, we're still streaming. So okay. Sorry to make you like sit through this. But let's see. So the lesson for today is getting familiar with large numbers written as powers of 10. So this is, as we look at this, hey, technically, I just want you to like look at this. We just did like 8 lessons on this stuff, and we're at this point where it's like, hey, we should do a quiz. And I'm just like thinking to myself, nobody really wants quizzes right now. So here's the thing, is that I've been getting daily feedback from you guys as you've been doing assessments. I've been able to kind of see how you're doing. I know that it's tough. I know that you're not getting them all right. I know that sometimes you have to request to see the answer. I'm hoping that you're learning as we're going. So here's what I'm doing, is that I'm going to push back on having an actual quiz. And because I've been getting some data on you anyway, if I needed to give a quiz grade, I would. Right now, we're just doing like pass fail. It's okay. All right, you're all passing because you're trying every day. You're trying. So if we look at this next chunk of lessons that we're jumping into, it's scientific notation. Now, my memory did kick in. right before we left school, we were actually jumping into this stuff. I was kind of pre-teaching you guys. Do you guys remember the videos of like the stuff zooming out into the universe and like and getting larger and larger and stuff like that? And do you guys remember my let's see. Do we got the papers? Nope, not that. Not Amazon. Not that. This. Do you guys remember do you remember my cart, my stack of papers? Do you remember like what this stack represented? Do you remember what this stack represented and what this stack represented? Let's back it up. Hopefully you do. So remember, this was to say that like, hey, every sheet of paper represents a million whatever, a million people, a million bucks, whatever. It was to help you visualize that. And then as we like went through it, is like, oh, well, if you take a little chunk of this paper and cut it out, this whole like little chunk of the paper would represent New Haven with 130,000 people, and you know, Chester, Deep River, and Essex wouldn't even be like a full square of dots, square of dots of a square of dots, you know, because remember this right here is actually 100 little dots, that one little square in there. So then you get the stacking sheets of paper, and it was like, well, what did this represent? So remember this stack represent like the little white papers in there that represented Connecticut, I think, and I think the pink stack represented California, and then this whole stack represented the 340, 50, whatever million people that are in the United States, and then this represented basically China, the whole population of the world, and then if you took off America, and there was a big chunk of it that was still basically China, and that was it for that. So we are coming into working with the idea of working with very large and very small numbers. Just going to do a time check here. Boom. All right, 6 minutes. I want to try and get this fast. So when I look at like what does the lesson look like for today, here's the big thing is that I want you to get comfortable with naming numbers. You look at a number, and like this one right here, you look at this one and you're like, hey, all right, so I know that this is going to be thousands, this is going to be millions, this is going to be billions, this is going to be trillion. What the heck? Why is it all jumbled up? It's because this is an activity where you would match them up. I'm not going to have you actually match them up. Instead, I'll just show you the answer. This is what it would look like with everything matched up. So we would have, 10 to the third means you have 3 powers of 10. Remember, that's 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So when you look at that, yeah, 10 to the third is 1,000. If you were to multiply it by 3 more powers of 10, so 1,000 times 10 is 10,000, times 10 is 100,000, times another 10, 6 tens, that's a million. And that's where we get to this one right here, a million. We had explored this idea before, but another thing that we added on to it with the idea of powers was now the idea of, well, 10 to the negative second power, that means dividing by 10 twice. So that would be 10 times 10 is 100. It means like you're dividing by 100. So when you have this, that means 1/100th. And they've got this prefix of centi. So here's the thing. This is where I want you guys to remember that in my classroom, I'm going to get rid of my face. No, I'm going to get rid of my face. Yeah, all right. Hopefully my face is gone. Remember in my classroom, I had this on the wall at the top of my room? This long string here of place value and everything. Remember that, like, this is the way that I kind of want you thinking through when you get to these negative powers. -1 is a 10th. -2 is a 100th. 10 to the negative third is a 1,000th. 10 to the negative fourth is a 10,000th. And 10 to the negative sixth is a millionth. Just like 10 to the positive sixth is 1 million. So remember, we got that millionth for the 10 to the negative sixth, and the mirroring of it on the other side, million for 10 to the positive sixth power. You're going to see that symmetry. Basically, if you remember one side of it, it's going to make it very easy to get the other side of it and the names of everything in the other side of it. Okay, so today's a familiarity day. Remembering, okay, coming back to this, that you've got your thousands, followed by millions, followed by billions and trillions, Okay, that's as far as that goes. But what's after trillions? You know, tree, trillions. That's try. So then you go to a quadrillions, and then five, quintillions, and then you know the prefixes just keep going beyond that. Trillions is about as big as we care to go. So remember this. I'm gonna try and put like a screenshot of that in Classroom just as a reference, so that you don't have to keep going back and forth with it. I mean, you'd be going back and forth, but like not in the video. So let's come back to this. Yeah, the idea today is just like connecting these powers of tens to their names. Powers of tens to their names. Powers of tens to their names. I would call this one a 100th, and this one a 1000th. So I'm gonna skip ahead. I think that this is also a little valuable thing, which is saying like, which is saying, hey, you know, if you had a power of 10, 10 to the third power, and that's in the thousands. So you see that 10 to the third is in the thousands. What's something that's measured in thousands? And so when you look at this list, they go, oh, the number of students in a school. It could be measured by thousands, not at our school. But yeah, at some schools, it could be the number of students. The population of an endangered species, when it gets to like the thousands, they're endangered. The cost of a car that barely runs. I love that. That would be a $1,000 car. Yeah, it'd be a car that needs a lot of help. So, and the number of brain cells in a jellyfish. So, okay. Then you get to millions. I just like going through these. You can read them, but the population of a state is going to be measured in millions. The cost of an expensive car, the most expensive car in the world. So I can't even name a car that would be $1 million car, because it's not part of my world. But those who know cars and know dream cars and stuff like that, $1 million buys you one heck of a car. All right, so we go to billions. You know, billions you need to think of. So these are your benchmarks. Why are we going over this? It's because in the back of your head, when you hear a million, you should have the idea of like, oh, that's like big populations. You know, like populations of a state would be 1 million. 300 million population of the United States. You're building benchmarks in your head so that you can reference them. So when we get to billions, there's not a lot of things that we talk about in billions. So these are ones where you really want to burn them into your memory. 1 billion. So the population of India, the population of China, the population of the world is going to be, or the number of students in the world. So not adults, but the number of student age people in the world is going to be close to 1 billion. The number of brain cells in a monkey. Okay, I don't know how to compare that. They're using brain cells, but the number of trees in the United States. There's a lot of trees in the United States. But, you know, there's also a lot of empty space and everything. But when you add up the trees, okay, apparently it's around in 1 billion. Now, a trillion, again, we don't get that number very often. But this should just, like, expand your mind. Is like a trillion is significantly bigger. When you start talking about a trillion, you're talking about the number of stars in a galaxy. The amount of wealth produced by a developing country, a developed country in a year in U.S. dollars. So that means a developed country, not a non-developed country. So it means like, you know, a country like the United States. I'm not even going to name countries. You're in the United States. You're in a developed country. We're not talking about a country that's in poverty. Okay. So number of stars in a galaxy, that's trillion. The number of brain cells in 10 students. I love that you have to gather 10 students together, get them in a room, and then if you took their brains and plopped them on the table, you know, put the brains here, we had 10 brains, then we would have, you know, we'd have, you know, apparently 1 trillion brain cells. Okay, again, this is all about familiarity with the numbers. I am skipping the vast majority of this lesson. You can see I am just scrolling right through this. So here's the thing. I am assigning numbers 1, 2, and 3 for this. And so this would be the time where you'd like pause the video and you'd go ahead and you would try, you know, try number 1, try number 2, try number 3. And then unpause the video and come back if you wanted solutions to it. I'm not going to go over like all the solutions. Instead, what I'm going to do is like just, you know, scroll, and then you could pause the video to see the solutions for these. I know I say that, but like for maybe one or two of them I'll go over. So go ahead, try the problems, and then when you come back, unpause this, because I'm going to show you the answers now. Ready? Okay. So that first problem here, you had to match the number to its name. You had a bank of names and you had a bank of numbers. So again, you know, hopefully you're using place value. This is the tenths, that's the hundredths. So it would be 1/100th, you know, so B would be that. So when we match them up here, so you can kind of see all of them at once. A is 5, 1 million. B, there you go. C, D, E, F. Boom. Okay. The second one I asked you to do, it said write each expression as a power of 10. Now, I didn't teach you how to do this, so this is more of an extension. This is me in the video saying it's okay if you did the assessments thing and you got them incorrect. It's okay. What they wanted you to do was see that in each of these numbers, you could take out 2 powers of 10 here. So look at this and look at its answer, 10 to the second power. And what you would be left with is 423 times 100 would give you this 42,300. Okay, and the same thing happens with this, 2,000 times 3 powers of 10 times 1,000. You know, 2 times 1,000. So, again, I'll pause. I'll just leave this on the screen so that you could check over possible answers. The one that I would want you to get correct is the first one, just to prioritize things. And the last one, the third one, was pretty much the same as the second one, except they gave you them in word problems, and it was the same type of thing, except some of these had words where you had trillion cells. So maybe that one we look at that one, 37 trillion cells. So whoop, okay, and it's fuzzy. It got all fuzzy on me. Let's see. Okay, so 37 trillion. Just looking at that. What did they want us to do? So I hear 37 trillion. So I know that I'm going to have to set this up as 37 and then just go from there. Okay, so if I start adding zeros, that's 37,000. If I add 3 more zeros, that's 37 million. So if I add 3 more, all right, 37, that'd be, okay, so that's thousands, millions, billions. So that's 37 billion. I know, okay, 3 more. And I've got, okay, thousands, millions, billions, trillions. This is 37 trillion. Now, what did they want you to do? They wanted you to write this as a whole number, like 37 times a power of 10. So how many powers of 10 do we really have here? Well, we have 1, 2, 3. Each 0 is a power of 10. 4, 5, 6, 7, 8, 9, 10, 11, 12 powers of 10. So this is a possible answer. Another way that you could write it is that you could go one step further and say, hey, what if we put the decimal place here or included this as a power of 10? Because isn't 30 a power of 10? So what we could do is take that 30, give it, you know, and divide it by 10. What's 37 divided by 10? You know, 37 divided by 10? Well, that would just be moving the decimal place over. It'd be 3.7. 3.7 times 10 is 10. This is going way beyond. So, you know, so like, but this is where we're going with scientific notation, is like looking at this. So I'd really be adding another power of 10. So we're going to write or. You could have 37 times 10 to the 12th power just by doing this. But we could also write this as 3.7. Take a power of 10 away from this and add it onto this. Times 10 to the 13th power. Now, you can get that same answer just by going over 12, 13 spaces, and then right here going, okay, there's a decimal there, and turning that into 3.7 times 10 to the 13th power. Okay, so that's a sneak preview of where we're going with this for scientific notation. Do you have to get it all today? No, you don't have to get it all today. All right, so again, we're just looking at introducing you to very big numbers and very small numbers. So the next lesson is looking at very small numbers. See you. Bye. So time to kill the live video. Ba-da-da-da-da.